Okay, so I might have lied to you just slightly in the last video. I thought I could fit all of the rest of this in a single video, but I decided that I would split it up. So this will be the last video for section 11.4. So we want to first open up, this is a homework question, homework 11.32. So I'm going to go ahead and do that and just get it ready to go. So usually when you go to that main StatCrunch tab, usually you just launch the website and move from there, but we can also choose data sets from our textbook. And this is a chapter 11 homework problem number 32. And you might have noticed it says stacked here, and so we're going to have to deal with this a little bit. Notice this does not look like what's given in our note sheet. This is all one giant column with all of the math, social science, and English scores in a single column. And that's not going to do us any good, because if we run a test, StatCrunch really is not going to be able to distinguish between which subject is which. So if I want to split this up, I can go to Data and Arrange. And what I want to do is I want to split this column up. So the column that I want to split is the scores. I want to split the scores up, and I want to split them up by which subject they go to. You can open it in a new data table if you don't want to lose the original, but I'm okay with it just overwriting the original. Okay, so it created for me now new columns. So now I have an English, a math, and a social science column, and that looks like my table here. Okay, so what are we talking about here? We've got 3 independent random samples of full-time college students, and they were asked how many per hours a week they studied outside of class, and their responses and majors are shown. So these aren't scores. These are actually how many hours per week do you spend studying on your own outside of class. So the hypothesis that we want to test is the mean number of hours studying, does it vary by major, or are they all basically the same? And we're going to basically do a test from top to bottom and then perform a post hoc analysis if it applies. So we're really left on our own here. So let's see. The first thing we want to do if we're going to run a hypothesis test is let's write our null and our alternate. Again, the null would be that these are all the same, that the mean studying time is all the same, so that the mean for math is the same as the mean for social science, which is the same as the mean for English. And again, kind of as a reminder, what that's saying is that there's no association between studying time and major. And my alternate would be that at least one is different. Or that there is some kind of an association between these. Okay, so I've got my null and my alternate. Let's make sure, are the conditions met? Okay, so the first one we want to check is the sample size large enough? So if I actually go through and count these, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And they're all the same. So good, all of the n's are bigger than 25. So we check that one. Now, we can't tell about the homoscedastic condition until we actually run the test. That's where that shows up. So I'm going to go ahead and run it, and then I'm going to come back and note whether it's okay or not. So I'm going to go ahead and go here, and I'm going to go to my stat ANOVA one way. The columns that we want are the 3 that have been parsed out. And I'm even going to go ahead and click this, even though I don't know whether I need to or not yet. It doesn't hurt to just go ahead and have it on my screen. And so I'm going to go ahead and compute at this point. And I've got everything possible that I could possibly need right here. So let's see, I need my largest and my smallest standard deviations. So my largest is like 3.17 and my smallest is 2.8. Oh, sorry, no, my largest is 4.21. Okay, I'm going to go back to my page. I'm going to try to remember those as I flip back. So I have to make sure that the max SD is less than or equal to twice the min. So the max was like 4.41, and this one was 2.8. So if I go ahead and calculate that, it looks like it might be close, but 2 times 2.5 would be 5. So that one's going to be, that right-hand side is going to definitely be over 5, right? So this is going to work. This is 5.6. So we meet both of our conditions, so we're good to go there. So we're going to go ahead and compute everything, which we technically already have done. We want to record that F value and that P value. I did not look at those yet because I didn't know if we were good, but we are. So now I can see that my F value is about 8.37 and my P is 0.0005. And now I'm ready to write my conclusion. So let's see, since P is, again, they said nothing. So when they say nothing, we default to alpha being 0.05. So in this case, it's definitely smaller than that. P is less than this. So we're going to reject the null. And what we can say at that point is we can conclude that at least one of these means is different. Now, at this point, I have no idea which one, or if maybe they're all different from each other. So this is where we go look at the confidence intervals that are created, and I apologize ahead of time for all of the switching back and forth. So let's see, we're going to take English away from math and English away from social science. So before I forget that, I'm going to write that down. We're taking, whoops. That's not what I want to do. Okay, so we're going to take I don't know why this is really messing up. Okay, there we go. We're going to take the mean of English away from math at first. And then we're going to take it also away from the social science. So then I'm going to flip back again. When I take the English away from math, everything is positive. I noticed that. But when I take it away from the social science, I get a possibility of 0 in there. So this one, everything stays positive. This one, this is possible. What that tells me then is that the mean of the math studying time is bigger than the mean of the English. Again, all I'm doing is moving this to the other side. And on this one, when I do that, it means that the mean of the social science could possibly be equal to the English. Again, it doesn't mean it absolutely for sure 100% is, but it's certainly possible. That's what we learn. Because again, there's a 0 in that interval right here, but it's not the only thing in that interval. There are some negatives, there are some positives. So it's kind of a anything goes kind of scenario here. Okay, then my last one is math being subtracted from social science. And everything in that one, I'm very sorry about all the back and forth. That one, everything is actually negative. So when we're subtracting the math from the social science, we get everything being negative. So what that tells me is that the social science is definitely less than the math. Okay, so I've got all the information here, but it's in a very kind of unfriendly or unusable form. So what we want to do now is we want to do that nice clean version where we do the underlining. So we want to write them in order from the lowest sample mean to the highest. So if we look at their sample means up here, it looks like it goes social science, English, and then math. So we're going to do social science, English, and then math. And we're going to underline any of them that included 0. So it was the social science and English that included 0. So that's the underlining. And so now what someone can tell very quickly is that it looks like the math hours studied, on average, studied outside of class is definitely higher than the social science and the English. And the social science and the English are so close together that they could be the same, we really don't know. One big note that I want to make is to watch the ordering of the subtractions. Right? It mattered very much how I read that, like which one came second and which one came first mattered. And how they say it is a little bit confusing. And the reason why I want to call your attention to that, specifically why I'm making a point to that, is because StatCrunch is not consistent from person to person and from trial to trial how it does that. So I just ran this, and what my StatCrunch spit out was this version of all of them. You might be running it and following along with me on the screen, and yours might come out with different intervals in different orders. So yours could possibly, it's possible that on this one, yours would have come out as doing English minus math. Yours might have come out in the other order, but it would have had the same meaning. Instead of coming out greater than 0, it would have come out less than 0. And what that would have then told us, we would have moved this over, and that would have told us that English is less than math. And that's the same thing. English is less than math is the same thing as math is greater than English. It's just a different way of saying it. So I just want you to be very careful that you will get the same results as me, and you should get the same results as anyone else in the class if you do it correctly, even though that little intermediate step might look different. And I don't know why StatCrunch isn't consistent on that. I feel like it should come out the same every single time for every person. But I've noticed whenever I do these with my in-class students that everyone's is kind of just random.